Well, for these normal distribution problems, using the calculator, for the first one, so what is the distribution? When they're talking about the distribution, they just want the mean and the standard deviation. The mean was 18, standard deviation was 6. And when you're finding the probability, you're always looking between two values. So if an American is randomly chosen, find the probability that this American will receive no more than 21 Christmas cards. So that means no more than 21 or less. Now when you go into the distribution, you use right here. So you have to hit the second because that's in blue, distribution. And then you go down to normal CDF. Now our lower, we want 21 or less. So you can use -1. This just means a really small number. So you could leave that, or you could put -9999999. And then the upper is the 21. And then your mean, which in this one is 18, and standard deviation is 6. Then you paste it and hit enter one more time, and then there's your probability, 0.6915. If an American is randomly chosen from the probability that this American will receive between 17 to 20 cards, well, we go back into distribution, the second one, and our lower, we want between 17 and 20, so it's going from 17 to 20. Our mean and standard deviation are the same. Hit enter a second time. You get the 0.1968. The last one, 65% of all Americans receive at most how many Christmas cards? So this case, instead of the percent, we're looking for the number of cards. So instead of the normal distribution, we use inverse norm because we're looking for the opposite. And hit enter. Now your area is the percent below. Since this is 65% of all Americans receive at most how many cards? So at most would mean what number and below. So 65% is below. So you put your 0.65, your mean, which was 18, standard deviation 6, and there's your 20. Let's try another one. On a planet far, far away from Earth, IQ on the ruling species is normally distributed with a mean of 118, and that's where this one came from, and a standard deviation of 17. Suppose one number is randomly chosen. Let X equal IQ of an individual. Find the probability the randomly selected person's IQ is over 104. So we want 104 and larger. We're looking for the percent, so we go into distribution, normal. Now we want it 104 to be our low value and up. So put a big number. Our mean 118 coming from part A, standard deviation 17. Paste it and hit enter, and there's your answer. Part C. A school offers special services for all children in the bottom 2% for IQ scores. What is the highest IQ score of a child can have and still receive special services? So that means the bottom 2%. So below 2%. We want to find the score. We're looking for the score. So that's the inverse. The area, 0.02. Mean from part A and the standard deviation, 83. What happened, you probably put 2 in, and that's how you get the 0.83. Find the interquartile range for IQ scores. Okay, interquartile range is Q3 minus Q1, and that's why we have to find Q1 and Q3 first, and then if we subtract those, we get the interquartile range. So the IQR was just the 129.47 minus 106. Now to find these two, when you're working with quartiles, this is the smallest number. And then Q1, the median. Q3, and the largest number. Notice that there's 4 parts. It breaks into 25%. So this is the lower 25%, and then this is 25, 25, and the upper 25. So they add up to 100. So we're looking for Q1. 25% of the data is below it. We're looking for the value, so again that's inverse norm. So second distribution, inverse norm, and there's 25% of the data below it. And then the mean and standard deviation were the same. So it would be 106, they wanted 2 decimal places, 106.53. Now Q3, notice, goes from here. So if we want to find this one, 25, 50, 75, 75% of the data is below it. So when we go into the distribution, we want inverse norm, and we want 75% of the data to be below, which gives us the 129.47. So when you're finding a value, you use inverse norm. When you're finding the percent, you use distribution, the normal CDF.